So internal resistance, we've got a cell just here that we've said has got an EMF of 1.5 volts and an external resistor that's 1.3 volts. That means that the internal resistance across it there'll be 0.2 volts. You've got to assume that in every cell it's got some kind of internal resistance, but you can't measure the EMF using a voltmeter. You can only measure the voltage across the resistor. So you've got to work backwards by taking individual pieces of data. So we would say the EMF is the terminal PD plus the lost volts. The external resistance equals what you start with. So the EMF doesn't really change, however if the current changes it affects the lost volts and the terminal PD. So that is what you start with, it doesn't change. So the EMF equals the terminal PD, so that's the volt using the voltmeter what you can measure, so I've labelled that V, and the lost volts you can't measure directly either, but you do know the current, and because it's a series circuit the current will be the same here, and then you don't know the internal resistance. But V equals IR, so EMF is voltage, terminal PD is voltage, and lost volts is voltage. So that can be rewritten, so EMF equals IR plus IR, and then Ohm's law. So again I can rewrite that, so EMF equals I times R plus R, so that's our total resistance. So voltage equals current times total resistance. So as I said, you can't measure the EMF of a battery directly, you've got to take measurements to do so, and you do that using the equation. The first thing to do is to compare the equation to y equals mx plus c. So you rearrange it, so V equals EMF minus your lost volts, and then you can rearrange that again, so voltage equals minus R times R plus your EMF. And when you compare that to a y equals mxc graph, on the y-axis you're going to plot V, on the x-axis you'll plot the current. The gradient is going to be negative gradient, but that's fine because minus R equals a negative gradient, so that the negatives will cancel. And your EMF is your y-intercept. So you'd end up with a graph similar to this.